Alright, so welcome. Today we'll be talking about the next step of what you're going to do, and that's going to be working with trigonometric ratios. Now, the reason why we're working on trigonometric ratios right now is because with square roots, sometimes you're going to have trigonometric ratios, especially with the Pythagorean theorem you just learned. You're going to be using certain type of measurements. Okay. Now, what actually happened was the history of trig real fast is that some philosophers back in the day, probably 2,000, 3,000 years ago, in the Middle East, were recognizing, hey, you know what? When we make triangles, no matter how big they are, if the angle stays the same, so if I keep angle x, I can write a ratio of two sides of that right triangle, and it will always be the same for no matter what the size. And so what they did was they went down and they listed all the angles of certain triangles, and they listed all the possible combinations of sides, so like opposite divided by hypotenuse, or adjacent divided by hypotenuse, or opposite divided by adjacent side. And so adjacent just means next to, so this is the adjacent and this is the opposite leg of x. Okay, now if I wanted to switch it up, if I wanted to move my angle focus from x to y, those two would just switch. The hypotenuse would stay the same, but we're just going to keep x for now. Okay. Alright, so what they did was they wrote them down, and they actually were very helpful because if you could tell the ratio, percentage, if you could tell this decimal of these two together, or these two, or these two, whichever combination, you could actually find missing angles. So trig was born because people noticed some relationships. Okay, all right, and those relationships do involve square roots sometimes, so we're going to have to work with that. So what we're going to do first is go over this little saying right up here, and this is SOHCAHTOA. Now I know it looks like a Native American saying. It sounds like SOHCAHTOA or something like that you would see in an old racist cowboy movie. But this is actually a really good saying because it helps you remember the trig ratios. Okay, so the first one we're going to focus on is going to be the SO. And if you notice, it's got O and H right next to it. Well, guess what? I got an O and an H right here and an S. Now, what does that S stand for? That is the sine. Okay, so sine of x is equal to opposite divided by hypotenuse. Voila. That's it. That's that ratio. All right, now I'm going to go over the cos, and that's definitely going to be cosine. I'm going to use x. That is going to be opposite divided by the hypotenuse. Okay, because it's CAH. So C, oops, look at that. I even messed up. Adjacent divided by hypotenuse. Okay. All right, so see how SOHCAHTOA can help you even correct inaccurate ratio writing. Okay, and then finally, the T stands for tangent. So tangent of x equals opposite divided by adjacent. I had to think about that because I didn't want to make the same mistake I made with cosine. Okay, now I know it looks like sin, cos, and tan, but please understand that stands for sine, cosine, and tangent. Okay, and these are your trigonometric ratios. So you set them all up however you want. Okay. All right. So now here's the thing: is that we're going to write this down. We're going to actually pick some numbers. So let's actually pick some numbers. Let's get rid of those names. Let's keep the x as our focal point. Now the angle is definitely the hugest part because the x is the focus point of it. And remember, if I move my focus point from x to y angle, I'm going to be changing my answer because I'm going to be dealing with a different adjacent and a different opposite side. Okay, oops, yeah. Let's just move this back. Alright, so let's come up with some actual sides. Let's do 5, 12, and 13. Okay, so if I wanted you to find sine of x, so sine of x would actually be the opposite, which is 12, divided by the hypotenuse, which is 13. So this would be 12 over 13. Okay. And in the beginning, we're just going to be writing these, just setting them up, just getting the correct ratio. Okay, now cosine of x is going to be adjacent, so we're not going to do the same patterns. We'll get rid of this. Okay, but adjacent, you're going to look here, and that's going to be 5, and then you're going to go there, and that's going to be 13. So it's going to be 5 divided by 13. Voila. As you can see, it's a different ratio. If you're getting the same ratio for two of them, you're doing it incorrectly, okay? All right, and then what we're going to do is we're going to go back, get rid of this because that was for cosine. And tangent is going to be opposite divided by adjacent. Okay, so that's going to be 12 divided by 5. Okay, voila. All right, now, just a quick hint. Usually sine and cosine's ratios will always be under 1. So if I divide, I should always get a decimal less than 1. Tangent can be over 1 or it could be less than 1. So it's the one wild card that you really can't kind of like check your answer and say, oh, that's what I should have gotten, you know. Let me move this back. Okay. All right, now let's say that we switch our focus from x to y. So let's switch it up here. Let's get rid of this. Let's get rid of this. Okay, now if I switch them, sine of y is going to be 5 over 13 because it's opposite over hypotenuse. Cosine of y, which looks like cozy, is going to be 12 over 13. And tangent of y is going to be 5 over 12. And if you're starting to see, like, wait, that looks familiar like the one we just did, there are some actual cool relationships. So the sine of one angle is equal to cosine of the other angle, and vice versa. So those two will always be equal. That's some really cool relationship. And tangent of one angle is just going to be the reciprocal of tangent of the other angle. So it's really kind of cool. All right. Now these two angles, just so you know, and this is a little bit of geometry coming your way, those two angles should add up to 90 degrees. Now some of you guys are going, wait, hold on. In the past, I've learned in my past math classes that all the angles inside of a triangle add up to 180. And we already know this is 90. Okay, so that's a right angle right there. So if that's already 90, that takes care of half of our stuff, so those two should add up to 90. Okay. All right, let's take some actual looks at how to work with this. So let's say we're given a triangle where we only know one of the legs is 12 degrees and it's opposite the 40 degrees. Or it's 12, just a length of 12. Let's say feet, you know, whatever. Okay, you could actually find these other spots by just using simple tricks. So katoa is what we're going to use to help us out. Now, if you notice, it depends upon which side I want to find. So if I wanted to find this side, I would be using a different trig ratio than if I wanted to find this side because two different formulas. Because of the two different sets of ratios I'm actually working with. So I'm going to solve for the hypotenuse first. Okay. All right. And I know that I have the opposite side. So if I have the opposite side and the hypotenuse, I'm stuck using sine. Okay. And the reason why I'm using sine, whoops, let's make that non-capital, is because I'm using 40 degrees as my angle of reference. My anchor angle is what I like to call it in trig. So sine of 40 is going to be equal to 12 divided by the hypotenuse. I'll just say h. Now, if you notice, I just have a simple equation, and most people get scared by this. So before we go any further, I'm going to show you what that actually is. All right, so what I'm using right now is I'm actually using Desmos, and I'm going to show you guys exactly what's going on. All right, so here's the thing. Before you ever use any kind of calculator with trig, you need to go to the settings menu and change it to degrees. All right, until you get to pre-calculus, you won't even touch the other part. So basically from here until you're in pre-calculus, you'll be using degrees. All right, so now, for example, I wanted to show you what sine of 40 was. Sine of 40 is just this really complicated decimal. Okay, so technically this is just a number. All right, and if you remember me talking about it, sine of 40 is equal to the ratio of the two sides, the opposite divided by the hypotenuse, and this just happens to be that ratio side. Okay, it's not a pretty number. For example, there's some really pretty ones like sine of root 3 or of 30 is going to be 1/2. That's actually a really cool property. Sine of 45 is going to be this nice number. That's not as pretty. Sine of 90 is amazingly just 1. And sine of 0 is just 0. So it's some really cool stuff to work with it. So just remember, whenever you're dealing with sine or cosine of an angle, like for example, let's do cosine of 40. Let's do tangent of 40. These are all just going to be different ratios, okay? Now also, don't mess up the ratios. Don't use the wrong trig function for the wrong problem, because you'll be using a different number than what you should. So you have to be very careful as to what you do, okay? Okay, so now that we've just concerned that this is just a number, we're going to treat it like pi. We're going to leave it like pi, and we're going to leave it alone. We're not going to write it the decimal form. If you do, you're cutting off numbers, and that's not good. So this is a number equals another number divided by h. So we need to solve for h. So what we're going to do is times both sides by h. Okay, and we get h sine of 40, or h times sine of 40 if you want to have it be exact, equals 12, which is really cool because now it's a number times a decimal right here equals 12. So if I wanted to solve for it, I would just divide both sides by sine of 40. Okay, remember that's just a decimal. It's a really weird decimal, and we're going to let the calculator do the majority of the work. Okay, now what happens is these two sines of 40s cancel out. I'm left with h is equal to 12 divided by a sine of 40. Okay, now that's going to look really scary because I'm dividing by an actual word right now, but remember, the sine of 40 is just a ratio of two sides. So let me show you how to put it in a calculator. Right, so I'm going to get rid of cosine and tangent for a second. We'll just focus on the sine of 40. Now, what I'm technically doing is going 12 divided by sine of 40. I'm doing 12 divided by this decimal. But the calculator already knows it, and it's going to go on forever in the calculator, so I can already leave the calculator, let it do its job, and I get 18.66. Probably want to round to the nearest hundredth, so I'd probably go 18.67 and just work with it that way, okay? All right, and so what I could rewrite this answer as 18.67. Voila, I now know the length of the hypotenuse. Now here's another key to check your work. The hypotenuse should always be the longest side. Okay. Now, what could I use for right here for finding this? Could I use trig again? Yes, you could. You would actually probably use, I'd probably use tangent of 40. You could use cosine of 40, whatever you want to do to actually find it. It's totally up to you. So I'm going to do tangent of 40 is going to equal 12 divided by that side. So we'll call that x. We'll call this x. Okay. Or you can do cosine of 40 is equal to x divided by 18.67. Okay, now this is not exact decimal, but it's actually a lot better than what we need. Okay, now what I'm going to do again is I need to get x alone, so I need to times both sides by x to get x out of the bottom of the fraction. So it's going to be x times this. So x times, okay, and x tangent of 40 is equal to 12. And then I'm going to divide both sides by tangent of 40, and I'm going to get x equals 12 divided by tangent of 40. And if you remember that it's a different decimal, I'm going to do that on my calculator off to the side by tangent of 40. And that's going to be 14.31, or 30. Okay. All right. Okay, so that's some pretty simple stuff right there. And then on this calculation, if you notice x is in the numerator, so all I need to do is multiply both sides by 18.67. So 18.67 times cosine of 40. And yes, each method will get you a different process in how to find the answer. Okay. All right, and 18.67 times cosine of 40. Guess what? It actually gets you the same exact thing, 14.30. Okay, so as you can see, there's actually two different ways to do that type of problem to work with it. Okay, now normally to find the missing angle, you would just subtract 40 from 90 and get 50, and that's pretty simple. Okay. Alright, so I know this problem now is set up like this. I don't have any other angle to subtract from 90 to get this angle, so what I'm going to do is show you how to set it up. And if you notice, if we get x alone, we're all good. So what I'm going to do is do the inverse of tangent to both sides, and it's going to look like this. Okay, I do tangent inverse to both sides, and what happens when I do that, these tangents cancel out, I'm left with x, and I just go to my calculator and do tangent inverse of 16 over 14, and I'll show you how to do that. So I literally type in tangent, and I press shift and 6, and that gets me the power button. I put a -1 in here, Then I move my cursor over to the right one, and then I go 16 divided by 14, and voila, I now have that angle, which is 48.8 degrees. And that's how you find missing angles by using inverses. I will talk to you guys later. Have a great day. Bye.